Good evening, everyone, and welcome to the second evening of Science Belgium 2021. I'm very happy that you're all here. My name is Flona, and I'm one of the hosts of this evening, together with my co-host, Monica. So good evening, Monica.
Hi, good evening. Welcome, everyone.
Hi, Monica. So Science is a great initiative, isn't it? It's actually a worldwide event that wants to deliver interesting, fun, and relevant talks of the latest scientific research and in an accessible format to everyone. And so normally, Science Belgium takes place in pubs all over Belgium, although Miss Corona has forced us to change plans last year as well as this year. Nevertheless, we have an amazing program for you, and our first speaker of today is Marlies van den Bent. Hi Marlies, how are you?
Hello, I'm fine, thank you.
Great, so you're a postdoctoral researcher now in the Center for Cancer Biology at the VIB KU Leuven.
Yes.
But today you're here as a representative for Infopunt Proefdieronderzoek, which is a Belgian organization that aims for transparency and spreading correct information about how and when and where laboratory animals can be used in research. But you will tell us all about it, of course.
Yes.
So I'm very curious to hear your talk, Marlies, and I'll give you the virtual floor in just a minute. So to everyone who's watching, please feel free to ask questions during the talk in the comment section. We'll show them at the end of Marlies' talk on the screen, and then she can answer all of your burning questions. So is this okay for you, Marlies?
Yes.
Yeah, okay, great. So then the virtual floor is yours. You can start your amazing presentation.
Thank you. So I'd like to start with telling you something you probably all know. There is a lot of science in our lives. If you have a headache, you can take a painkiller. Because of our understanding of the reproductive system, millions and millions of women can take contraceptive pills every day. If you undergo surgery, you might need a blood transfusion. And very relevant example is, of course, the corona vaccine that was recently developed. And I hope to receive my invitation quite soon for that. And a lot of these scientific breakthroughs have been realized because of animal research. So a few important medical breakthroughs of the last 100 years include the use of insulin for diabetic patients, the polio vaccine, pacemakers, HIV treatment, immunotherapy for cancer patients, and of course the corona vaccine. And in all these medical developments, animals have played an important role. And so I'm going to tell you today a bit more about the how and why and the relevance of animal research today. So I'll start with telling you which animals are used and why. And for that, I found you the most recent numbers. So every year, the most recent numbers of how many animals and which animals are used in Flanders, Belgium, and Europe. And so I'll show you the numbers for Flanders here. So the most used laboratory animal are mice, with more than 150,000 mice in 2019. And then there's also birds, fish, rats, a bit less common. Also farm animals are used, pigs, cows, sheep, a few other rodents like hamsters, reptiles, amphibians, and then very few cats, dogs, and also monkeys. And so in total, there are about 250,000 laboratory animals in Flanders in 2019. And to compare this with the meat industry, there are about 28 million animals in Flanders only in March 2021. So that's a whole different number, but just so you know how to compare. And so what are these animals being used in? Most of the animals are being used in both fundamental research and translational research, as you can see in the graph here. So what is the difference between fundamental research and translational research? Fundamental research answers questions like, so how does the brain work? Or what biological mechanisms make sure that cancer will develop? And so these questions are answered by fundamental research, while translational research focuses more on, okay, so how can we treat this brain disease? Or which drugs would help to cure cancer? And so these two research categories are the main categories in which animal research is used. Then there's also some regulatory tests, education and breeding, but this is much less. And just so you know, there is a very strict regulation on the use of animals in research. Since 2005, it is forbidden to use animals for cosmetic testing in the EU. And also today, it is forbidden to sell cosmetic products that were tested on animals outside of the EU. Also, human primates are not allowed in animal experiments like chimpanzees or orangutans. It's forbidden. And you can also not use animals for the development of tobacco products. And very important, if there is an alternative which will give you the same information as the animal experiment, you are legally obliged to use the alternative approach. And so also something, if you then have to do an animal experiment, you need to choose the least complex model organism. So if you can do your experiment using a worm, you're not allowed to use a mouse for this. So talking about mice, the mice are the most commonly used laboratory model. And that is because mice and humans are 85% genetically similar. That's quite a lot. And as you can see in the graph, the organ systems of mice and human are very similar. It's also very, well, relatively easy to genetically modify a mouse. So if you want to study, for instance, the role of a specific gene in the development of the brain, you can generate a mouse where you remove this gene, and then you can see what happens to the development of the brain in this mouse. And this makes it easy to study the role of specific parts of the DNA. And also, since mice are so often used in research, there is an extensive toolbox available. There are a lot of reagents that you can use for your experiments that are specifically for mice. And so these reagents will not work on pigs or cows, and that's why many labs work with mice, because it's so commonly used. And so the mouse is an experienced lifesaver. This is just a list, but it's definitely not a complete list of all the research areas where mice played an important role. It starts from AIDS to tuberculosis, stroke, really a lot of medical breakthroughs where the mouse played an important role. And the mouse was awarded a lot of Nobel Prizes, as you can see. So then a less commonly used animal in research are dogs. But I wanted to discuss them because dogs are like more pets. And so dogs played an important role in the development of, in finding out what the role is of the pancreas in insulin production. And so because of this, many people with diabetes can now take insulin and live an almost normal life because of this. Also, dogs are used in veterinary sciences. In the development of drugs and vaccines for dogs, these actually need to be tested, and so then they are tested on dogs. Also, safety testing, the step before a new drug is used in humans, they are first being tested in dogs to find out how the drug can be metabolized in different organs and what the concentration of this drug is in the blood, for instance. And also, dogs have a lot of naturally occurring cancers, and dog tumors are similar to human tumors, and so they respond also similar to the therapies. And so also this research can be used to treat, well, to know more about human cancers, but also to treat dog cancers. And so the most used dog race are the beagles, because they have a very gentle character, and also because there is historical data available. So you don't have to repeat every experiment with the beagles because there is already data available to compare with. And just to stress again, dogs are only a very small amount of animals in the total amount of laboratory animals. It's only 0.01% of all experiments. And then there's the non-human primates. And these are 98% genetically identical to humans. And that's why they are interesting for certain specific types of research. For instance, their brain is very similar to the human brain. The mouse brain, the surface of the mouse brain is actually smooth, while the human brain is more like a walnut. It has grooves and everything. And so the non-human primate brain is actually much more similar to the human brain than the mouse. So for certain experiments, you'll want to use these monkeys. For instance, a treatment for Parkinson's disease, deep brain stimulation, was found because of this research. And also how depth perception is developed during the development of the brain was found because of this research. And also in infectious diseases, monkeys are used. They were very important for the development of the polio and the Ebola vaccine. And also in research in AIDS, to investigate the mother-to-fetus transmission of the virus and how this could be blocked with antiviral agents, these non-human primates played an important role. And they can also be used for behavioral studies, like for investigating treatment of anxiety and depression. And again, monkeys are not the most common lab animal, not at all. They're only 0.0001% of all animal experiments, but I just wanted to show you why they are sometimes used. And so what happens after the experiments? There is a Belgian organization that finds adoption parents for dogs that retire from their lab activities. And also there are organizations that try to find housing for monkeys that are not used anymore in research. And so they can then spend the rest of their lives in a nice environment. And then something to note from the statistics, many animals are actually not reported in the statistics, like yeast or worms or flies, because they are invertebrates. They are not counted as official lab animals, and these are not in the statistics, although a lot of experiments are done on flies and on worms, and a lot of fundamental processes have been understood quite well because of these animals. And so when can researchers use animals? It's not just up to us, it's actually very highly regulated. So first of all, if you're a starting researcher and you want to work with animals, you'll need to do a course, an exam, and you'll get a certificate that proves that you have the sufficient education to work with animals. And then your project needs to be written into a proposal. You need to specify what you're going to do, what is your research question, what you want to gain from the experiments, and this then goes to the ethical committee. And this ethical committee consists of different experts with different expertise domains in order to be able to evaluate your proposal from the different angles. And also there are at least 2 independent members, so not connected to your institute, in this ethical committee to guarantee that this committee is actually independent. And they will then critically evaluate your research proposal. And if it's not okay, you'll have to resubmit and rewrite your whole proposal. And then also after your project is finished, you'll have to submit a report, which will also be evaluated by the ethical committee. And they will then see if you gained enough information from the experiments you did, and they will take this into account when evaluating future applications. And so an important concept in animal research is actually the 3 R's. The first one is replace. So we try to aim to replace animal studies as much as possible with other methods. It's even mandatory by law. If it's possible to gain the same information with an alternative method, you have to use the alternative methods. So in order to reduce the amount of animals used, you can replace it with something else. That brings me to reduce. I've already said it. You have to try to limit the amount of animals that you use. So you'll have to make a statistical calculation to find out what is the minimal number of animals I need for my experiment, so that you don't use more than that. What you can also do is, if you study the effects of a certain drug in a mouse model on the liver, you can also study the effect on the brain. Maybe there's an effect on the brain, so you can use multiple tissues from the same animal in order to gain as much information as possible from your experiment. And then there's also bioluminescent imaging. I'll come back to that later. I'll show you how it works, but this can also help you to reduce the amount of animals that you need. And then the third concept is refine, which means that we want to minimize the stress during the study that the animals experience. So this means that every researcher needs a certificate. You have to ensure that they are correctly trained to work with the animals. The optimal housing situation is figured out for each animal, and we try to use as much as possible innovative technologies that the animals have as less stress as possible. So what about the alternatives? Maybe we can replace animal research completely by something else. I'll show you which alternatives there are already being used today. One of them is cell culture. You can actually take cells from an organ and culture them in a dish. And you can grow these cells and you can then use these cells in experiments, for instance, to test specific drugs. You can even grow these cells into 3D structures and add specific other cell types to your 3D structure. So you have like a mini organ that you can create. So this is being developed, and we can already do a lot with this. So this is definitely something to consider. If you can answer your question with only cell culture, you should do that. Then there's organ on a chip. That's a quite cool method where you have this microfluidics chip with different chambers that are connected with each other. And then in every chamber, you can put a specific cells from a specific tissue. And then it's like you have a lot of different organs which are connected to each other with small tubes where you can put a fluid that mimics the blood. And that's really cool. Although it's not yet very far, we can definitely not replace a living mouse with this, for instance, but it is a start that can be used in toxicology tests, for instance. And then there's computer models. You can do a lot of modeling of biological processes on the computer. For instance, the picture I show here is a computer model for metastasis of cancer. So you can definitely model this, and you could predict the influences of specific changes in the environment of the cells. But this is, of course, only a prediction. And to make a good prediction, you need to have good information about what happens when you change something. So if there's a system, a biological system that you don't understand very well, then it's very hard to model it with computer models because you need to get input into your computer model. And then an alternative, it's not really an alternative because you still have to use mice in this example, but it's the possibilities for imaging are becoming much better. And so in this example, you can see the growth of a tumor in a mouse. And during the treatment, you can image the tumor. And you can see that it decreases during the treatment. And so this way, you don't have to use a lot of animals where you euthanize a few of the animals on every time point to see how the tumor decreases, but you can actually image it in live animals. And this way you can use less animals for your experiment. And so I'd like to argue that every method is actually a piece of the puzzle. You can do a lot with computer models. You can do a lot with in vitro experiments in cell culture, but more complex things are hard to study if you cannot use an in vivo model. For instance, I'm a cancer researcher, so you probably have heard about the role of the immune system in fighting cancer. It's very hard to model this in a dish, to have an intact immune system in a living organism with a tumor that is growing. This is still the best way to study the role of the immune system in fighting cancer. But however, I think there's a lot of information to be gained already from these alternatives. And I think we can, in the future, move toward these alternatives as they grow better and better. Then I'd like to say a few words about science, media, and politics. Sometimes there are these shocking pictures or these harsh titles in the newspaper. And this really shows that animal research is still a sensitive subject in the public debate. And of course, we as researchers, we agree that it's unacceptable to mistreat animals that are used in research. That's something I want to be very clear about. However, the pictures that are shown in the newspaper, they're not always representing the truth. And also, they don't give much context. So I think there is still some responsibility that has to be taken by the media. It's very important to use correct pictures and provide some context, and don't use clickbait titles because this will only, this doesn't give any correct information. For instance, the picture that you see here, one of my colleagues was able to trace a picture back to a lab in Vietnam. And what the person on the picture is doing with the mouse, this is absolutely not the way how you inject a mouse. So this picture is completely wrong, and still it came in a Belgian newspaper with this clickbait title. And then also, putting a pro-animal research versus contra-animal research is also a difficult thing, because we as researchers, we don't want to fight for more animal research. We just want to show the value, and we want to do it correctly and communicate openly about what we are doing and what is the value of these experiments. And so, of course, in this public debate, there's also a certain responsibility of the animal rights organizations. Of course, it's super important that these organizations exist, and they keep an eye on animal welfare in different situations, and they have done many good things for animals. But sometimes the message that they give doesn't really provide the correct information, and sometimes they rely more on emotions and not really on facts. And this way, you risk to misinform the public, which is, of course, not very good. And then there's the government and the politicians, and they also have quite some responsibility in this debate. Because, for instance, the Green Flemish party, Groen, they propose to have a tax on animal research, or to put a quotum, so a maximum amount of animal research that can be done in Flanders. But this can also be dangerous, because if you put a tax on animal experiments, then you kind of introduce a bias in the research that is being done. And you'll find that politics will be guiding science, and not the important medical questions that need to be answered will maybe not be answered because of this. And maybe the most important argument against quota on animal experiments is that if you have stringent quota here in Belgium, then probably animal research will just happen somewhere else. And then maybe all these companies and universities will relocate their animal research to China or other Asian countries. And we do know that these countries are not so strict on animal welfare. So the total amount of animal welfare would certainly decrease when this happens. So this is something that we don't think is a very good idea. And therefore, we propose that it's important to listen to the scientists when policies are made up, and don't just propose some rule, but talk to the scientists and see how can we together find a way to increase animal welfare in laboratory animals. And of course, there's the responsibility of the scientists, that's us. So we need to openly communicate on the animal research that we do. We need to do it right, that's very important. We need to follow the rules, and we need to be open about what we do and show the value of what we are doing. And that's why Info.punt Proefdieronderzoek was founded. There was a lot of frustration and disappointment about the communication on animal research, and therefore Info.punt Proefdieronderzoek was founded to play a role in the public debate and try to address misinformation in the media. And we'd like to engage in a dialogue with everyone. So here on the pictures, you see my colleagues, Lisbeth and Jeroen, who are on canvas even in the debate. So we try to inform the public as good as possible. And so we have even written a little book. You can buy it. It's very interesting. It's in Dutch. And also VIB has a nice brochure on animal research. And if you have more need, now the pressing need for more information, you can go to our Facebook page, to our Twitter, to our Instagram, to our LinkedIn, to our website. And if that's not enough, you can email us. Voilà.
Great. Thank you, Marlies, for this very interesting talk. For everyone who has questions, you can ask them in the comment section. We'll be sure to show them and then ask them to Marlies. But I will start off with a question, if you don't mind, Marlies. So you mentioned that animal research is forbidden for cosmetics, but you often see these, it's mainly influencers then who bring out a cosmetic product and then they are saying, yeah, it's cruelty-free, and then, so is this then just marketing that they are doing?
I think so, but it's something that I often notice, that if I tell my friends, look, but all cosmetics should be not tested on animals because this is actually the law in the European Union, then they're quite shocked. So this is something that is not really known. So I guess it is marketing, because normally you cannot buy any cosmetic products that have been tested on animals anywhere in the world in this in the European Union.
Yeah, okay, it's good to know, because I think sometimes they might want to raise the price if they say it's cruelty-free. Okay, great. Let's see if there are some
Yeah,
questions
so
also.
maybe we can move to one of the first questions of the chat. So
Mhm.
Goofy's B says, does it mean that intelligent mice could actually experiment on us because of the biological similarities? Going back to your slide of the mice, humans, 95%.
Yeah, that's an interesting point. I don't think that that will be the case, but it's true that we have a very big genetic similarity with mice, and that's why the research that we're doing and the organ function that we see in mice is so similar to humans, and that's why they are such a good model. That's yeah.
Okay, so maybe a follow-up question that it's a bit controversial. So it's 95%, right? So then how can it be that now most of the papers we cure cancer on mice, but eventually we then not find it in humans? So how different is that 5%?
I believe that when the papers say that they cure cancer in mice, that this is also something that is more clickbait than actually true, because I work in cancer research. I do research on cells, but also on mice, and completely curing the mice on a magical way, it is still not possible, sadly. So I think it's not because of the genetic difference. I think the papers exaggerate the effects of the treatment a bit, just to make the title of their article a bit more sensational, which is it's sad thing, because it's sad for cancer patients who then suddenly see, oh, cure for cancer, and then it turns out not to be true.
Well, yeah, it's really a pity in this case. But and here Sha also asks. So
Yeah, I was
does
also
it
just
was
looking for the question.
it was very interesting about the alternatives, but I wonder what would be the restrictions of limitations at this stage for mass adoption.
Yeah, that's a very good question. I think that the complexity of a living body is still not being reflected in all these alternatives. So you can indeed do the organ on a chip. You can put different organs in different chambers and then connect them with a fluid that looks like blood. But still, this it's very hard to mimic also the effect of hormones that come from the brain or from other glands in the body, or the immune system is so complex, it's very hard to mimic that in an artificial model system like that. And so I'm afraid that it's still the only way to find out the influence of all these different things is by using live animals. Also, something like Parkinson's disease with the tremor that the patients have, that's something you cannot model right now with this organ on a chip or in a cell culture model. So, or behavior, like mice, Alzheimer model mice that have learning disabilities or memory loss that you can only see in a living animal and not in this cell culture model. So these specific cases are too complex to just put on a chip or in a dish. And so that's why we still need animals to do research on these things.
Yeah, and you think that probably there will never be a point where we can replace animals completely by some kind of other system that we might optimize,
I
even with the
think for
computer and
these
the predictions. When you say when we gather more information, maybe they become better.
well, the alternatives will become better and better, and we will be able to replace more and more animals with these alternatives. So that's great. I can only support this. But for these super complex things like a tremor that is driven because of defects in your brain, this is something that I don't see happening in the next 10 to 20 years, because I cannot imagine how we would be doing this. But yeah, maybe there are smarter people than I that can do that, and I would fully support that.
Great. But then also, I'm also wondering, how do you decide then which animal model you use? Because you mentioned that you use monkeys sometimes for Parkinson's disease and so on, because their brains are more similar to humans. Or then in other cases you use flies or you use mice. Like, how do you decide which animal model would be best? I mean, yeah, for the brains, okay, it might be easy to go for monkeys then, but
Yeah, although it really depends on your question. If it's something super specific that you cannot do in mice, then you might consider going to more complex organisms, but you'll have to ask your question, can you not do it in mice? Because you always have to try to get the least complex organism as possible. So for things, if you want to genetically modify an organism, then it's best to stick with mice because that's just the easiest way to do. It's very hard to genetically modify. Well, it's definitely harder to genetically modify other animals. So studying the effect of a specific gene is much more easy in mice, for instance. So you only go to more complex animals in very, very specific cases.
Okay.
And now going back also a bit to what you say, less complex animals. So actually, how do you define an animal? Like you're saying now that Drosophila, like the flies, are not an animal, or like a worm.
They're not a
is
lab animal.
No, so how do you make this distinction, and how?
Yeah, there is an official definition of a laboratory animal. So it's all vertebrates, and also octopus. What's octopus in English?
But I think it's octopus in
Squid.
English.
Squid. Squid is not a vertebrate, but it's still counted to the laboratory animals. And also the mammals in the third stage of the pregnancy are also considered as laboratory animals. So yeah, there's an official definition of what is a laboratory animal, what do we count, and what do we not count.
Hannah is jumping on this with a question. She's asking, do you think we will soon have? Oh wait, do you think we will soon have regulations about using invertebrates in research?
That's a good question. I think these invertebrates are not counted as laboratory animals because they have much less sensory mechanism. Like they say that flies do not experience pain, and so that's why they are not really counted as a lab animal. So I'm not exactly sure about that. I don't think there will be regulations on that, although it has become stricter, like the squids were included at a certain moment.
About the squids, your colleague is helping you, Jeroen, with the cephalopods. Yeah.
Yeah, thank you.
Yeah, he was also doing an FYI in the comments, so it's not a question, but I'll put it on here for a moment. When you were talking about when you would inhibit or stop animal research in Belgium, that this would be taken abroad anyways. So he said that this exporting animal research to other countries because of strict regulations in Belgium is already happening. So
yeah,
it's a bit unfortunate.
That's a bit unfortunate. There's a lot of administration that you have to do because of these animal experiments. It's important to follow up all the mice that you have and document everything very well. But I think indeed companies are doing some of the research in China because the regulations are less strict there, and so it's like a difficult balance because you want to have maximal animal welfare, but you also don't want to make it too difficult for the researchers because then everyone goes to, well, I'm saying China here, but I mean, other countries where the regulations are less strict.
And how about money? How does this, because I can expect that if you export it, maybe it's not as much as regulations are also, that is cheaper to make these experiments. Which factor is money also in this equation?
I can imagine that it's probably cheaper to do all your experiments in more low-income countries. On the other hand, it's also less ethical to do that. So I would argue to keep the experiments here and do it as well as possible according to the regulations.
Yeah.
Anna?
Yes. Yeah, go ahead.
Anna follows up on the question, but there are studies about like emotions on bumblebees, for example. You don't think that would force us one day to have regulations?
Well, I haven't read these studies, so I cannot really comment on that. Sorry. I'll have to do some research on that and then I could say something about it.
Yeah. Okay.
It's very interesting.
Yeah, I'm also wondering, you always meet people in your life who are really against animal research. And so these people, they usually don't like to listen to all of the explanation that you can give about why animal research is important and why we do it and how strict the regulations are. So if they use their emotions in this debate while you come with facts, how would you try to solve it, or how would you try to convince them that it is actually not as bad as they would want you to think? Or if they're really against it, how would you debate with this person?
I think it stems from just having a different philosophy. If you if it's your belief that an animal life is exactly the same value as a human life, of course, then it's not, you cannot test medicines on animals because to save humans, because that's just not worth it. But I think in our society, we see that if you can have an acceptable amount of animals suffering in order to solve a terrible medical condition that where many humans will die from, then our society defines that now as acceptable because of our general belief, the general belief that this is okay. But indeed, if you don't agree with this, I think it's very hard to convince people of the value.
Actually, Goofy's Bees weighs in on the other side. So, shouldn't stricter regulations on animal testing be compensated with more flexibility on human testing? Which is a even more trickier question to answer.
Yeah. Yeah, that's a hard question.
I think that's an ethical debate.
It's an ethical, indeed. It's an ethical debate. Do you want to have more tests on humans directly? Do you want to test the drug not first in animals but directly in humans, with the risk that these humans will have very bad consequences? Do we accept this as a society, or do we say no, we want to test it first in animals because we don't want humans to die because this drug was never tested in any other living animal? It's a choice that we make, and right now the choice is, I think, that we first test it in animals and only then we go to humans.
And how many people would be in line for this more, for a testing that may be not so, how do you say it? That you may die from, or that you may have some severe illness from after you are tested, or these kind of things. Who would want to do that even? So if you're less strict with the humans, then or will you start forcing people? Or this is a whole other debate, I think.
Well, our active audience says yes, directly on humans, spare the mice.
Yeah, that's a different philosophy, of course.
So I think he's a volunteer to, or she volunteer to be tested on.
Yeah.
Okay.
And at least on about a bit more of a scientific and your experience or mouse experiments. So for instance, for a mouse experiment to work, how many mice do you have to try and test until that experiment is good? Because eventually we waste, between brackets, a lot of mice on testing until the...
It depends. So for instance, I'm a cancer researcher and I test new drugs for T-cell lymphoma, which is a terrible cancer. All the patients die. And so, but I first test it in vitro. I first test it on cell lines. I first test my drug on cells from one mouse that I take from the liver or the spleen. I test it in a dish. And if I see that it works, I estimate how big is the effect, and based on that, I can determine how many mice do I minimally need to make my experiment work. So I will never just try a drug in 20 mice because I can. No, I read the literature. Which doses do I need? Is it already described in other cancers? So you have to really prepare your experiments and just not act. Because this will also never be considered a good plan by the ethical committee. You're just not allowed to do that.
Yeah. Okay. There's some information being exchanged in the comments section here as well. I think this was again about the emotions of the bumblebee. I guess so. Shah says to the question of Anna, I think this was from the emotions of the bumblebee. That I guess it depends on the types of study and ethical consideration. Do they study emotions using behavioral observations or using electrical stimulations? And again here, Jeroen is also commenting that it's indeed a combination of several factors: ability to experience fear, how developed the nervous system is, and even the ability to plan into the future. It's an evolving discussion. Okay. And the discussion is continuing in the comment section.
Yeah.
This is great.
Yeah, I don't have any experience with invertebrates, sorry, so it's very hard for me to comment on. But I'll do my research. I know to prepare this for next time.
Yeah.
And maybe Marlies, to give us a bit of a feeling, do you need to do a lot of paperwork after you do an experiment?
Yeah, well, if in preparation of the experiment, it's already a lot of administration because there's this administrative system where every mouse is documented where it is, in which cage, in what room of the whole university. And so if you move a mouse from one cage to another one because you want to make two groups, then you have to change it in the system. And then so afterwards you have to adapt and to say, okay, this mouse has died because it was euthanized in the experiment, and then you have to click in the system that it was euthanized in this and this and this way. So there's a lot of administration, which I think is a good thing, but it's a lot of work.
Yeah. All right. I think for now the questions in the comment section are done. Well, at least until someone.
So maybe the last burning questions, they can type it, and otherwise I guess that we will have to start wrapping up.
Yeah. It's still a discussion that's going on.
Interesting.
Which is great.
Yeah.
Great. Yeah.
If this was a bar, it would have been really nice.
Yes. Yes. Next year.
Next year.
Or let's hope so, at least. We thought so last year as well, that this year would be the year that we could do it in the bar again.
Indeed.
Oh, well,
one step at a time.
Yeah, true. Okay, but if there are no more questions that are coming in, I would like to thank you, Marlies, for this very interesting talk and for answering all of our questions. So thank you for joining us today. I want to tell the audience that if you're still thirsty for more science, there's a second event today, and there's also 2 events tomorrow. So maybe we'll hope to see you there again here on the YouTube Live of Pint of Science Belgium. And that's it for now. So thank you everyone for joining. Thank you, Marlies, for your talk, and see you soon then.
Okay, bye.
Thank you very
Bye.
much. Bye-bye.